Now, we'll try to prove a couple of identities. What do you mean? We'll figure it out in a minute. We're trying to figure out what this equals. Cos square theta plus sine square theta, right? So before we do it in the conventional way, let's try to do it in a graphical way so that we can visualize it better. Okay, so I have already plotted the graphs of cos theta in green and sine theta in black. So from this, can we plot the graphs of sine square theta? We already have the graph of sine theta. Can we plot sine square theta? We can. How? So this value is 1. When theta is 90 degree, sine theta goes to 1. Okay. So for any values of the angle theta between 0 to 90 degree, the value of sine theta is less than 1. And when theta is 0, sine theta is 0, theta is 90, sine theta is 1. So when theta is 0, sine theta is 0, so sine square theta is also 0. As simple as that. So I'm going to mark those points which belongs to sine square theta. So when theta is 0, sine square theta is 0. No doubt about that. When theta is 90 degree, sine theta is 1. So sine square theta is also 1. So we get this point for sine square theta as well. What happens in between? If theta is between 0 to 90 degree, my sine theta is less than 1 and greater than 0. Right? And what happens if we square something which is between 0 to 1? So in this interval, sine theta is greater than 0 or less than 1. Let's say half. Let's say half. If we square half, do we increase the value or decrease the value? If we square half, we get 1 over 4. This is 0.5. This is 0.25. So if we square something less than 1, we actually reduce its value, right? So apart from these 2 points, everywhere in this interval between 0 to 90 degree, sine square theta is going to be less than sine theta because we are squaring something less than 1. So you can do this exercise. You can just literally sit down with the calculator and try to compare the values of sine theta and sine square theta. You have to get something like this. Let me do it in a dashed line. So the dashed line is sine square theta. Then again, from 90 to 180, you will have sine theta less than 1 and greater than 0. So if you square it, you should get something less. You should get something like a hill or a bump. Right? What happens if theta is negative? If theta is negative, my sine theta is negative. But the moment we square it, it becomes positive. So we cannot have a negative value for sine square theta for obvious reasons. So we should have something like this. This is my sine square theta. Does it make sense? Like that. So apart from 0 and 1, it will be less than the curve of sine square theta. And here it cannot be negative, so it will be flipped to the other side. Okay, that is my sine square theta. The same story will happen to cos square theta as well. If I plot cos square theta, you should get something like this. Again, it cannot be negative now, so it will be something like that. Here as well, it can't be negative. Something like that. Nice. So, if you compare sine square theta and cos square theta, it looks like a DNA, double strand, like this. So, if you see, when my sine square theta with the black dotted line is 0, my cos square theta is 1. So when theta is 0, let me repeat, when theta is 0, sine square theta, black dashed line, is 0. Cos square theta, the green dashed line, is 1. So if you add those two, you get 1. When theta is 90 degree, my green dashed line is cos theta, cos square theta, that is 0, and black dashed line is sine square theta, is 1, is the opposite case. So again, they add up to 1. You can try all these values of theta, calculate the values of sine square theta and cos square theta, add them together. You'll see that for all values of theta, these two, the two dashed curves that do like this, will always add up to 1. Very interesting. So if you add the dashed green line and the dashed black line at all values of theta, you should get a constant value which is equal to 1, as if they are complementing each other. Whenever the black dashed line hits a dip, it reduces, the green dashed line compensates. It's like that. Okay? So this value cos square theta plus sine square theta is nothing but 1. That's the hard way of doing it. There's no reason to do it like that. But why did you do it like that? To understand. It's not about just doing it, but also to figure out how many ways you can do the same thing. So let's say we have our conventional triangle theta, we have L, we have base, we have the height. What is my sine theta? Sine theta is L over H. Oh, that's a fat L. L over H. Cos theta is just the base over H. What happens if we square them? So let's say sine square theta, L square over H square, cos square theta, B square over A square. If we add them, sine square theta plus cos square theta will be L square over H square plus B square over A square. On the top we'll have L square plus B square. What is L square plus B square in a right angle triangle? Pythagoras theorem. H square. So the top, the numerator is nothing but H square, which is nothing but 1. So that's simple. And you have proven the same thing graphically, right? Alright, there are a couple more identities. So if sine square theta plus cos square theta is equals to 1, what happens if we, oh actually we can't do those.